Classless interdomain routing CIDR is the opposite of VLSM because in VLSM you have a subnet mask, obtain the network ID, broadcast ID, etc. Here it's in reverse. Here I will tell you because before, yes, in VLSM they gave us the subnet mask and we told them the amount of the increment value and the available host IP addresses. Okay, this is their catch. We knew the amount of the available IP addresses from the subnet mask. Now in reverse. Now someone will come to me, let's say it's a customer, and those guys said, use something nice, 200.200.0.0, just an example. Of course we need the subnet mask because it's CIDR, and we need this subnet mask to be so economic and efficient only for our 50 employee that we have. That's it, as simple as that. Okay, so if it was as simple as that, then I will do something. You have only 50 employee? Good. And we will definitely need the network ID and the broadcast ID. So actually you need 52 IP address. So you need a subnet mask that fits a 52 IP address. So I will do something. I will draw the chart of the binary. So I will type 1, 2, 4, 8, 16, 32, 64, 128, 256. I'm exceeding 8. We can do whatever we want, we cannot, it depends on what you want today, and that's it. Okay, so if I did that, what I want to do right now will be, you need 52 IP address. So interesting. Is one IP address is enough? No, one IP address is not enough for 52 guys. Is 2 enough? Definitely not. 4, 8, and 16, none of these alone individual can be enough for 52 employee. They are 50 employee, but I added network ID and broadcast ID as backup, so I'm considering as 52. Is 32 IP enough for you? Never. Is 64 enough? Well, yes, but it exceeds. Well, okay, it does exceeds, but we know that the architecture of subnetting is always built on 2 to the power of something, so we can only have these numbers that came up by 1 multiplied by 2 by 2 by 2 all the way. So 64 is better than nothing, better than 32, so I will go with 64. And then what I will do right now, I will type /64. No, there is no such slash. No such slash. But I reach 64. I will do something simple, and that was to draw the line. I drew the line now, and whatever on the right side, the amount of values on the right side reaching the very first one will be replaced with zeros. So a 0, another 0, a third 0, a fourth, a fifth, and a sixth 0. So that means I have 6 zeros. The total of the subnet mask is actually 32-bit minus 6 zeros equal to 26 ones. 26 ones. So yes, the subnet mask should be /26. 26 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 31, 32. In decimal to 55.255.255. I need to convert that based on the video that I gave you before, and these 8 equals these 8. So 0, 0, 0, 0, 0, 0, and suddenly I find these 2 equal 1 and 2, 1, 2. So I need all to activate these 2 and deactivate these 6. 128 plus 64 is 192, and these I don't care about, so that would be .192. I have teached you how to convert from binary to decimal and vice versa. Number 1. Number 2, since now you know that the network of red or green, the network of 200.200.0.0 is /26, then I would need you to pause the video, grab another paper, and now apply the skills that you gained by obtaining out taking out, okay, or acquiring out the network ID, broadcast ID, range of valid IP addresses from a network that you know its prefix and subnet mask. Prefix and the subnet mask. This is very important. So that was example number one for CIDR. Example number two, whatever other example. Let me clean the screen. This is not a real life in mathematics class back in the high school where the teacher really wipe out the board and I start saying I did not copy everything down, because now you can just stop the video and copy everything down. Okay. Example number two would be 55.0.0.0, and they asked me to design a subnet mask for that prefix that fits 150 employee. Yes, why not? So first I will say, actually sir, you would need to remember that you need an extra network ID and broadcast ID. So instead of -2 before, now we are adding +2. So 152 IP address in total that you need. Okay, I would need my chart kindly. So that would be 1, 2, 4, 8, 16, 32, 64, 128. We can continue like 256, 512, depends, we might need them, we might not, because this chart is not related to the old one. This is not just to make use of it. Now I'm start to thinking that 1, 2 is not enough for 100 person, 32 is not enough, even 128 is not enough for 152 person. So it seems that I need to use this number. So 256 is enough. So just before that, I would need to draw a line. And this is step number one. Number two, step number one, count until you reach to a number that equals or is bigger. Rarely you might find it as equals. Mostly you might find it as equal. If you will mostly find it as bigger. If you ever found it as equal, no problem. It will not be like embarrassment for you, because we have already added the backup of 2. If you wanted a factor of safety, it depends on you. Like if you wanted to multiply the number by 1.5 to reserve an extra amount of IP addresses for future uses, it depends on you. In the exam, they will not ask you to do it in that way. They will ask you to design a subnet mask based on the current number of employees, the current number of used hosts, and that's it. So a bigger number or equals, no equals for 152 because 128 is smaller, but 256 is bigger. Good. So I will give a 0, second 0, 3, 4, 5, 6, 7, 8 zeros. If the total size or length of a subnet mask was 32-bit and I have 8 zeros, this leads to /24. Yes, /24. That would be nice. Good. So if it was /24, then what I would know, then it has 24 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Correct. 17, 18, 19, 20. New. 4. And then 8. And decimally. Is there a word called decimally? No, in decimal, I believe only. It looks like that. So the network would be 55.0.0.0 and because it has 3 octets as one, so that would be the network part and that would be the host part. So the first 3 octets are untouchable here. And what I want from you right now, simply to derive out the network ID, broadcast ID, and the range of valid IP addresses. As simple as that. Okay, example number 3 in today will be the network of 2.0.0.0, and the amount of employees was 1,800 employee. So +1 it would make them 1,802 employee. And based on the chart, actually 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. Be more smart. 1024 is not enough at all. 2048 is enough. 4096 is more than enough. So if I started counting, then I will definitely stop at a number that equals or bigger than 1800. 1000 is not enough. 2000 something is bigger than 1800. I will consider that, and I will start counting the zeros. So a zero, three zeros, 5 zeros, 7 zeros, 8, 9, 10, 11 zeros I have. So 32-bit minus 11 zeros equal 21 ones. Definitely the broad subnet mask will be /21. /21, and that will make it, let's see, /21 means 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32. If it was in that way, then what I want you to notice is that the third octet alongside with the first and two are a network part, while half of the third octet with all of the fourth octet are host parts. What does that mean? That means the first two octets are untouchable. The third octet is somehow touchable, somehow is locked. How would you know that? Well, you would know that by knowing the trick of the numerical value, adding the numerical value to this octet until you reach a number. This number will be the, I will solve it for you. I will solve this example completely for you. Okay, right now, I will only type this in the decimal, the subnet mask in decimal, and I will start the next example based on this one, like 255, dot 255, dot how many ones I have? 1, 2, 3, 4, 5 ones in this octet. 5 ones and 3 zeros. So if I wanted to look on that, 3 zeros, 1 2 3, I don't care about these, I care about 5 ones. This one, this 2 3 4 5. 128 plus 64 means 192, plus 32 means 224. With this one will be 240, with this one will be 248. So 248, the last octet is all zeros. So this is how a /21 looks like in decimal. Okay, so now based on the CIDR, I obtained, or I solved, the issue of knowing the subnet mask from the amount of desired hosts, and we are done. So the subnet mask in the slash form, in the binary form, in this one, whatever you want, done. Take a look, because I will clear the board and start a VLSM example now, because I know how many comments will be below this video if I did not do it right now. So 2.0.0.0, it was .0, right? Yes, 2.0.0.0/21. Show me now the network ID and the broadcast ID. Okay, I will show you. /21 means 32 minus 21 equals 11. So 2 to the power of 11 equals 2048, because I remember 2 to the power of 10 is 1024. This one is next, 2080 and 48 host IP address. And what I want to do right now is 2.0.0.0 is the network ID, and 2.0.0.1 is the first valid IP address. This number can never be the increment value. Why? Because it's bigger than 256, so I cannot inject it here. I will need to divide it on 256. So 2480 divided on 256 will be 8. Yes, just math in the brain, will be 8, and that sounds smart. This number is not bigger than 256, then I will never divide again. So I will stay here and I will take the 8 and do the -1 thing. So I will be 7. That will result in one single jump with an increment value of 7. One single divide means a single jump So this will definitely be full. This one will be 255. So I will jump here, and to that 0 I will add a 7. So the broadcast will be 2.0.7.255, and definitely the IP address before will be the last valid IP address. And that's it. Yes. And that's it. I'm tired already. Okay. I will not end the video right now. I need to end IPv4 today because yes, because we are done. Yeah, so just before I do that, I will need you to stop the video, take a screenshot, or write down the notes. I will prove to you that this one is correct. 2.0.7.255 is correct. How? By going to the web browser, and I will type subnet calculator in the web browser, and I will come here and I will clean the board now. There is a website called Online Subnet Calculator, and it was 2.0.0.0, and it was /21 255.255.248.0, right? Yes, it was in that way. I remember that. 21. Yes, I remember it was in that way. So they say that this network, since it's /21, then it should start with 2001 and it should end with 2000, I'm sorry, and should end with 207255. The first valid is this one, the last valid is that one. Don't use the subnet calculator before you pass CCNA exam. Please don't do that. This is just an extra info for you, because your exam is of 100 questions, 2 hours only. So don't depend on that. Be a master at manual subnetting so that you will win it. Please make sure that you will do it in that way. Okay, one last thing very important today, and that will be the private and public IP addresses. If every single IP address is allowed to be used on your computer, then you will never be able to guarantee that no one on earth, on any other location, will use the same IP address that you have just used on your computer. In that case, if you used 10.10.10.100 and you send a packet to the internet using that IP address as a source address, another person is using the same IP address, and that is very likely in that case, then the internet will say which one of you is really 10.10.100 and which one of you should I reply back the information to, because one of you requested google.com and the other one requested cisco.com, and I'm confused because I don't know who you are and who you are. I have no idea. So they came up with a solution called private versus public IP addresses, and also something different that I will talk about in chapter 4. But so far, to avoid the duplication, they came up with the private and the public. The private are available, and every single person can use a private IP address on their computer, their router, their switch, no problem at all. And the public are cost reserved. They cost money. You need to buy them. You need to purchase them from like IANA company from America, and they will be responsible for you. From RIPE NCC, yeah, RIPE, I believe RIPE it was. From RIPE, you will need to purchase that from the RIPE company. They will give you a public IP address that will be yours. No one is ever allowed to use it on their devices, but the private will be free and available to be used inside the company. So again, what will happen? Two things will happen. Internet, you are connected to the internet via your internet service provider router, ISP, and this is your small network. You will use the private here, and you will use the public here, and the public will be sent to the internet. The reply will be go back from public to public, and from the router or the provider, the public one, to your private. In chapter 4, you will understand NAT, and you will master the rest of this lesson, and that's it. Okay, what are the privates? Well, the privates is any IP address in the 10, no matter the subnet mask, any IP address from 172.16 to 172.31. In total, it will be /12. Here, in total, it will be /24 with all the small subnet mask inside it. And here as well, I'm sorry, this one is /8. And here as well, in total, anything that starts from 192.168 dot whatever until the end of 192.168, so that will make it /16. So 10.0/8 means 10 dot whatever is private. 172.16.0/12 means 172.16 dot whatever until 172.31 end. So 172.32 dot whatever is public, and 172.15 dot whatever is public as well. Don't use them inside your computers. And 192.168 dot whatever is public as well, private as well, because 192.167 is public and 192.169 is public as well. These are the privates. You need to memorize the privates, not the publics, because you will use the privates. Number one, the privates are much less than the public because these are their subnets only. If you gather all of them, perhaps the result will be 17 million only, and that's it. But the truth is that the total amount of IP addresses worldwide is in billions, 4 billions compared to 17 million. Means that the private is so few, but this means that inside your organization or network you can use up to 17 private IP address, and this same IP address will never be announced to the internet publicly. Thus all the companies worldwide can use the same 10 dot whatever, 172.16 dot whatever, 192.168 dot whatever inside their networks. No one cares. It's private. No one will know about it because it will not be announced to the internet. If you did announce it by yourself, by force, you are doing a disaster, and security guys will tell you the consequences. That should be the end of IPv4. Next video will be IPv6. Thank you.